first video of the year. We are going over real numbers. Real, R-E-A-L, numbers. And that's your table of contents, is real numbers. And like second period, immediately everybody then starts saying, so what, are there not real numbers? The answer is yes. So like yesterday we talked about rational and irrational. Today I will introduce you briefly, because it is very, very higher level math, like your senior year of high school level, that you will learn an imaginary number. There's a whole world of math that deals with the what if. So real numbers. So to answer that question that's in the back of your brain about whether or not there are unreal numbers, the answer is yes. We call them imaginary. Imaginary. You do not have to know this. It's just fun because y'all are pre-AP. So here's a glimpse into where you're going in your education. Yes. Imaginary numbers. There's only really one that I can remember that you'll cover before you graduate high school, and that is I. And it's a little squiggly I. He's not straight up, he's squiggly. And that's so he doesn't look like a 1. He's a little squiggly I. And I is not real. The idea of I is kind of a black hole, like dividing by 0. So there's this whole world of math where you kind of play the what if game. So like I can't actually create I. I can't divide by 0. But what if I could? Then what would happen? And so there's this whole branch of math that kind of deals with that. I can't do this, but if I could, this is what we would do, and this is the math behind it. Yes? Yeah, it's like all that. It's like imagine land, make pretend land, what if land. Like I can't defy gravity, but if I could, then I could do this. I can't travel back in time, but if I could, this is the math that would do that. Like there are people out there that deal with like the math of time travel. We can't do it, but there are people out there that believe that they have the math to do it. We just can't physically make it happen. Not yet. And that's the world they live in. They live in that world of, we can't do this yet, but maybe one day we can. So here's the math to prove this imaginary make-believe thing that can't happen now but might happen later. Okay? Like there's this story, I don't know if it's real, my dad used to tell me, that Einstein tried to work with invisibility, and he like worked for he was German. So he worked with some ship in World War II, because Einstein's not that old. Like he died in the 70s. Or 50s, 70s, 50s? Yeah, 70s or 50s he died. It has to do with my dad. It's either the year he graduated or it was the year he was born. But he tried to make a ship invisible. And so he like worked with that whole idea of mathematically how could you make something disappear. So it's crazy. So yesterday we dealt with square roots. I is the square root of -1. It does not exist. You cannot do it. It doesn't make sense, honestly. Is there anything you can multiply by itself to give you a negative? A negative times a negative is a positive. A positive times a positive is a... So there is no possible math that explains this. But there are equations out there and there are problems out there that have this as part of it. And since we're talking about fun math, that's like big world math, there are problems. It's a college, I'm going to have to look it up. There are problems that are out there that have $1 million prizes if you can solve it. I'm not even lying. I'll have to look them up and show you sometime. There are math problems out there that people are willing to pay you millions of dollars and you win big awards if you can prove this problem.
What kind of problems are they?
I'll try to find one and show you. They're pretty.
Advanced.
They're like those
Yeah.
whiteboard ones you see like movies.
Yeah, they're like Goodwill Hunting kind of problems. But no, it's like I wouldn't be surprised if any of y'all could like get up to that level. But yeah, like there's people willing to pay you millions of dollars
We should try it as a
to. I'll try to show. There's a video I show my classes that goes over it. It's yeah. All right. So let's talk about all the numbers that we do know. When you are a tiny fish in the tiny sea, red, orange, yellow, green, blue. All right, so we're dealing in the real number. We're in the ocean. The real number ocean. Now, up in the sky, we have the sun of imaginary numbers. He's not in the ocean. He's not in our real number ocean. When you were a tiny little tadpole in your tiny little classroom in kindergarten, and the teacher gave you blocks and said, count the pens, what did you do? It's not a trick. How did you count them? Count them. We count things 1, 2, 3, 4. When your teacher lined you up in kindergarten and counted you, how did she count you? 1, 2. No teacher in the history of kindergarten ever goes 0, 1, 2, 3, 4. When you were in kindergarten, you didn't go 0, 1, 2, 3, 4. We didn't use 0 when we were in kindergarten. When you were a tiny fish in your tiny pool, you counted numbers. What comes naturally? 1, 2, 3, and so on. We naturally count numbers 1, 2, 3, 4. It's what comes natural. When you count money, you don't think, I have no money. Now I have $1. Now I have $2. No, that's not how you count things. These are also called counting numbers, because that's the first way you learn math. Counting. Then, you grew up a little bit, and at some point, somebody introduced the world of nothing to you. It's weird to think that we have to learn about nothing. But then you learned 0, 1, 2, 3. You aren't much bigger, but just a little bit bigger. And these are called whole numbers. There's a little bit bigger fish. You were a little bigger, not much bigger. And then after that, teachers saw, okay, well now there's 0. Your inquisitive tiny mind probably thought, well, if there's 0, is there anything on the other side of 0? What's less than 0? When I was in first grade, my teacher taught me about negatives because I wanted to do 2 minus 3. Because I thought 2 minus 3 was 1. And so my teacher sat me down and she said, 2 minus 3 is not 1. If you only have 2 things and you take away 3 things, you would have a negative number. And it blew my 5-year-old mind. So, when you got to be a little bit bigger, probably not first grade like I was, but a little bit bigger, somebody told you that there were numbers on the other side of the 0, and you probably thought, what? So then you learned negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, so on. Keeps going, both directions. That's probably the first time you thought about the word infinity, because it just goes on forever and ever and ever in both directions. Infinite. These are called integers. You learned these in 6th grade. And now we're in 7th grade, and we're going to take all of these fishes, and we're going to swallow them up in our big 7th grade fish. And we are going to include all of these numbers on both sides of the number line. It is a big fish. It is the biggest fish of them all because there is nothing else after this, really. These are rational numbers. And our rational numbers are everything inside all these little fishes and anything in between. So you've got negative 4.2, 3.7, negative 1/2, 1/3, 2/7, I don't know, 4.8, whatever, keeps going. All kinds of examples, you can write your own examples. Now that we're in 7th grade and we know rational numbers, we know all the in-betweens, did you forget how you counted in little bitty tidy tadpole school? No, you didn't forget it. So all of these numbers are still inside of the big fish. So the number 1 is the littlest fish. You learned it when you were little bitty. But now it's inside of all the other fishes. You have that little kindergartner still inside you somewhere. Then when you were a little bigger, you learned 0. 0 is not, you did not count 0 when you were little bitty. You were a little bigger. And then you learned 0, 1, 2, 3. So 0 is a whole number, an integer, and a rational number. Negative whole numbers, so negative 4, is only an integer and a rational number. If you think about it, if you go and ask a kindergarten, how much is negative 3? They don't know. But you know, and 8th graders know, and 9th graders know, and high school people know. But you don't get smaller, you can only get bigger. If you ask a kindergartner, do you know how much 1 is? They'd hold up their, 1. So you could ask a kindergartner how much is 1, a 1st grader how much is 1, a 2nd grader, a 3rd grader, 4th grader. They all know how much 1 is. So a 1 is all of these families. And they are all inside of the real number ocean. Now, because you are in pre-AP, because you are special, and we like advanced math, there's another fish in our sea. He's not a rational number fish. He's pretty irrational because he doesn't have any bones.
It's a snake.
I drew an octopus in the other class, but I want to say he's irrational because he doesn't have bones, because that seems irrational to me. Here's our irrational jellyfish. Our irrational jellyfish is swimming in our real numbers, because he still exists. He's just kind of weird because he doesn't have any bones. And he's mean because he stings things. So our irrational jellyfish are numbers like pi, the negative square root of 15, the square root of 24, square root of 11, all of those numbers that we dealt with yesterday that don't have good answers. Those are our irrational jellyfishes. So he's still in the ocean, but he's not a fish. He's a jellyfish. So to practice, to make sure we totally get it, the number negative 4 is a member of which fish families?
Whole numbers.
He's a rational number.
He's an integer.
He's an integer. And what ocean does he swim in? He's a real number. So if you want to get real vague, he's a real number. What about 2/3? Which fish family is he in? Rational. Could you ask a kindergartner to show you 2/3? You could. Yeah, you're going to get that.
They might.
Yeah, maybe.
They'll be like.
0. This is always a fun one. 0. What fish families is 0 in? He's a whole number, integer, and rational. So remember, the older kids all know the answers, but the littler kids don't. Like a kindergartner or a tiny little preschooler might have a hard time explaining how much is 0. Okay? How much is 0? I don't know.